So the frequency, fundamental frequency is 1 by 2L root over T by M naught. Just keep on substituting the values. The length here is 20 centimeter, which is 0.2 meter. The tension here is 25 Newton. Mass, M is mass per unit length. It's not given. Like mass per unit length is mass divided by the length of the wire. It's not given. Instead of it, area of cross section and density is given. So okay, let's do these substitutions. Frequency is 1 by 2L root over T by M, which is mass per unit length, M into L. Now the issue is neither the mass is given, the mass is not given. Tension is given, but mass is not given. So what we can do is, let's multiply with area of cross section in numerator and denominator. Fazil, what is A into L? Area of cross section multiplied by the length of the wire. What is this quantity? Volume. And this is M into A. Noor, can I write something like volume by mass? What is volume by mass? It's 1 by density, right? It's 1 by density. So it's 1 by 2L root over its tension by area into 1 by density. This frequency 1 by 2L root over T by A into rho. So frequency is 1 by 2L root over T by A rho. Now just keep on substituting the values. How much is L? L is 20 centimeter, it's 0.2. Root over T, tension, how much is tension? 25 Newton. Area of cross section, 10 raised to the power minus 2 centimeter square. So I just write it as minus 2 meter square now. Density is 10 raised power 4. When you solve it, it comes out to be around 125 volts. Yes, is it clear?
Yes, sir.
Now, since only first harmonic is a part of your syllabus, so the type of questions are very restricted now. You can get extreme these type of questions only. Just note it down. Then we'll do next instrument. Written.
Yes.
Yes, sir.
Yes, sir.
The example of open organ pipe is flute. Flute is an example of open organ pipe. So let's say you have this open organ pipe. It's open from both the sides. The length of the open organ pipe is L. Here, this is the open boundary. The reflection is from this open boundary. Now, this is always an issue that you will ask how the wave can reflect from this boundary. There is nothing here. See, when we say boundary in physics, it doesn't mean uh, a wall or something which is very concrete. Boundary simply means there is change in medium. The pressure inside the pipe and pressure outside the pipe is very different. So this pressure due to pressure difference, there is a boundary. Boundary simply means there is change of medium. That's it. So here and here, air is same, but the pressure is different. So due to that pressure difference, this region is acting as a boundary. So you will have an incident wave here and a reflected wave here. The reflection is not from a closed boundary. The reflection is from an open boundary. So as the previous one, I'm writing the equation of incident wave A sine omega t minus kx. Then you can write the equation of reflected wave, which is A sine it's omega t plus kx. No phase change. When rays or when waves reflect from an open boundary, there is no change in phase. The rest of the calculations are same. You can use superposition principle, the same calculation. Superposition principle, the equation of wave will be y incident plus y reflected. Y incident is A sine omega t minus kx Y reflected is A sine omega t plus kx. Next, what we can do is we can take this A as common, amplitude as common. So I'm left with sine omega t minus kx plus sine omega t plus kx. So again, you have sine A plus B plus sine A minus B. So when you have sine A plus B plus sine A minus B, this will be, what is sine A plus B plus sine A minus B? That's 2 sine A cos B. So it's 2 sine A, which is omega t, B, which is cos kx. So this is the equation 2a cos kx sine omega t. This is the equation of standing wave. Equation of standing wave. So the next task is, this is x equal to 0. At x equal to 0, your y will be a. This is x equal to L, your y will be a. So next again, you have to solve it. See, y is equal to a because this is an open boundary. This system can have maximum displacement. Instead of a, I'm writing maximum. This is an open boundary. Your wave can have maximum displacement here. So I'm writing open boundary, boundary condition at open boundary. No, Fazil, here the reflection is from an open boundary. When the wave reflects from an open boundary, there is no change in phase. Earlier, in case of string, your boundary was closed. That's why I'm taking this plus pi, and sine plus pi plus theta is minus sine theta. That's the difference. Here the boundary is closed, but here the boundary is open.
Okay.
That's why. Very good. That's why no negative sign here, no plus pi here.
Okay.
No plus pi here. Next, what we can do is we can solve this equation. Y is 2a sine kx cos omega t. We will solve this equation using this boundary condition. Boundary conditions are at x equal to 0, your y equal to maximum. At x equal to L, your y equal to y is equal to maximum. So this is the equation number, I call this as equation number 1. Same standard repetition to equation number 3. What we can do is we can put 2 and 3 in 1. I substitute not 2, I am substituting 3 in 1. When I substitute 3 in 1, your y is maximum. Okay, just do one thing. Write this equation, then we will continue.
Sir, both are maximum.
Yes, Fazil, what's saying?
Sir, both are maximum, like equation number 2 and 3.
Yes, both are maximum because it's an open boundary at both the ends. It's an open boundary at both the ends. So this is again open, this is again open. So your wave can have maximum displacement.
Okay.
Done, sir.
So y max is, instead of x, I'm writing L, and your y should be maximum. 2a sine kl cos omega t, isn't it? No, this is cos kx, sorry, cos kx sin omega t, not sin, this is cos kx. So if I make these substitutions here, this is 2a cos kl sin omega t. Your y is maximum. Your y is maximum if your cos kl is maximum. So for y max, your cos kl should be equal to 1. This could be maximum only if your cos have the maximum value. Cos kl is 1 if your angle is n pi. This we have also discussed in beats yesterday. So I can write k as 2 pi by lambda n into L is equal to n pi. Pi gets cancelled out with this pi and you will get lambda n as 2L by n now. So this is the relation between wavelength, length of string and L. You can also calculate frequency here. Frequency is V by the wavelength. So you have V by 2L by N, the same expression as you get in standing wave in a string. But here the speed of wave V is root over gamma p by rho. This is the expression of speed. It's gamma p by rho. If I make these substitutions here, so frequency will be n by 2L into V, which is root over gamma p by rho. This is frequency n by 2L root over gamma p by rho. This is frequency. Next, what we can do is we can solve it for first harmonic. First harmonic, or you can call this as the fundamental mode. For first harmonic, put n equal to 1. I call this as equation number 4 and I call this as the equation number 5. I'm putting n equal to 1 in this equation. N equal to 1 in 4. When I substitute n equal to 1 in 4, what I get is lambda n is 12 by 1. Instead of n, I'm putting 1. Sorry, not lambda n now. Lambda 1 is 12 by 1. Your L is lambda 1 by 2. So in L length, you have half wave. So in L length, you have half wave. That means see, this is a full wave. Huh? I'm taking half wave in this way, this one and this one. From here to here, this is again half wave. 1/4 and 1/4, this is half wave. I'm choosing half wave in this way because at boundary, I cannot have node. At boundary, I should have antinodes. Antinodes means maximum displacement. Then open boundaries. So it will look like this. So these are antinodes. Antinodes means points having maximum displacement, and this is the node. Next, what we can do is we can calculate the frequency. For calculating frequency, you can substitute n equal to 1 in fifth equation. New one is 1 by 2L gamma p by rho. This is your fundamental frequency of first harmonic. Just note it down. There is one last instrument which is closed organ pipe. Then we will solve closed organ pipe.
Sir,
Yes.
can you show the graph for stationary wave?
Yeah, this is for the stationary wave.
No, so like before, like you drew one graph before the organ pipe, right?
Yeah, that one is for string, stationary wave in a string, right?
Yes, sir, that also.
Yeah. Yes. Yes, Abdullah, written.
1 second, sir.
Hmm.
Done, sir.
Okay.
That's it.
Okay. Yes, written.
Yes, sir.
Last instrument, which is closed organ pipe. So closed organ pipe means these are those musical instruments which are closed at one end and open at another. This is closed organ pipe. Like if you have a glass of water, and there are people who create music using that glass of water only. So that glass of water is in closed organ pipe. It's closed at one end and open at another. So wave is coming in this way, and it gets reflected in this direction. So in closed organ pipe, if you have an incident wave, if you have an incident wave, then the equation of incident wave is this. Equation of incident wave is a say incident wave is traveling along negative x-axis and reflected is traveling along positive x-axis. So you have y incident is a sine omega t plus kx because it's traveling incident is traveling along negative x-axis. Then it gets reflected. The equation of reflected wave is a sine omega t minus kx. Reflected wave is traveling along positive x-axis, but the reflection is from a closed boundary, so we'll get a plus pi also. Due to which this equation is now minus a sine because pi plus theta is minus sine theta omega t minus kx. Sine pi plus theta is minus sine. Next, what you can do is you can use superposition principle. Next, what we can do is we use superposition principle. So this is y incident plus y reflected. So y incident is a sine omega t plus kx. Y reflected is minus a sine omega t minus kx. Next, we can take a as common. Sine omega t plus kx minus sine omega t minus kx. So y is equal to a. It's sine a plus b minus sine a minus b. So this will be 2 sine kx cos omega t. So this is the equation of standing wave now, which is 2a sine kx cos omega t. This is the equation of standing wave in a closed organ pipe. The next thing is boundary condition. For boundary condition, we will use this is x equal to 0. At x equal to 0, it's a closed boundary, so y equal to 0. This is x equal to L, x equal to L, we have an open boundary, so your y equal to max. So I'm using boundary conditions here. I am using boundary conditions here. Boundary condition means at x equal to 0, your y is equal to 0. Let's call this as equation number 1. This as equation number 2. At x equal to L, your y is equal to max. Next, what we can do is we can substitute 3 in 1. When we substitute 3 in 1, then y is equal to 2a sine kl cos omega t. So your y should be maximum. This is maximum only if your sine kl is maximum. Mean the value of sine kl is plus minus 1. The value of sine kl is plus minus 1 if your angle is 2n minus 1 pi by 2, or for all multiples of pi by 2, sine is either plus 1 or minus 1. You can write your k as 2 pi by lambda into L is 2n minus 1 pi by 2. This pi will cancel this pi. So you can write that your lambda n is so if I cross multiply here, I'm taking this lambda n here and I'm multiplying this side with the 2. So it will be 4L by 2n minus. Lambda L is 4L by 2n minus. Next, you can calculate frequency. Frequency is V by wavelength. So frequency is V by 4L into 2n minus 1. So this is the frequency V by 4L into 2n minus 1. Next, you can calculate different harmonics. If I want to calculate first harmonic or fundamental mode. Put n equal to 1, when I put n equal to 1 here, so the frequency of first harmonic is V by 4L 2 into 1 minus 1. Now first of all, let's calculate the wavelength and length relation. Here we can do one more thing, like we can write V as root over gamma p by rho. Laplace correction, speed of sound in air. 1 by 4L 2n minus 1 root over gamma p by rho naught. This is the frequency, general expression of frequency. If you want to calculate first harmonic, let's name these equations. This is 3. Let's call this as equation number 4. This is equation number 5. For first harmonic, you can put n equal to 1 in equation number 4. When you do this substitution, you will get lambda 1 is 4L by 2 into 1 minus 1. You will get lambda 1 is 4L. You will get L is lambda 1 by 4. So in L length, now you have 1/4 wave. That 1/4 wave we will draw. This is one wave. This is 1/4 wave. This much is 1/4 wave. So we will draw the 1/4 wave like this. This is the 1/4 wave. This is the 1/4 wave. This is node. This is the antinode. Next, you can also calculate the frequency. So for frequency, put n equal to 1 in this equation number 5. When you substitute n equal to 1 here, you will get the frequency of the fundamental mode is 1 by 4L root over gamma p by rho. So this is about close orbit. Right? Let's note it down. Okay, just tell me when you have written. Fazil, Abdullah, can I change the slide?
Yes.
Done, sir.
There is one difference in sound generating from open organ pipe and closed organ pipe, and that difference is in open organ pipe, all harmonics are present. Like first harmonic, second harmonic, third harmonic, all harmonics are present in open organ pipe. So can I change the slide now? I need space to write.
Yes, sir.
Remember this thing. In open organ pipe, only, not only, all harmonics are present. First, second, third, all harmonics are present. But in closed organ pipe, only odd harmonics are present. Even harmonics are absent. So the sound of open organ pipe is richer than the sound of closed organ pipe. Open organ pipe can generate more type of musical sounds than closed organ pipe. So open organ pipe is better than closed organ pipe. Okay, just note it down. We'll do one last numerical on this concept. See, the question is, what should be minimum length of an open organ pipe for producing a note of 110 hertz. Speed of sound is 330 meter per second. So basically, this is for the open organ pipe. The frequency of open organ pipe is this for fundamental mode. So you have frequency, you have a speed, you just have to calculate the value of L. Calculate the value of L. How much is L?
Sir, 1.5 meters.
Yeah, 1.5 meter, right? So your L is simply V by twice of nu. Your V is 330. It's 2 into nu is 110. So it comes out to be 1.5. So this is the length of the pipe. See the numericals, basically the good numericals are from higher harmonics, third harmonic, fourth harmonic, nth harmonic. But since you have to do only first harmonics, you don't have many options in numericals. You can get only these formula based numericals on this topic. Okay, so this completes your syllabus. That was the last numerical that I have to discuss. Next, you want me to repeat that thermal properties that you have done with Tabish sir? It won't take more than 1.5 hours. Not today, but on Monday. If you want me to repeat that thermal properties, we can do it on Monday. Or you want to do self-study now?
So we'll do self-study.
You want to do self-study, okay. Okay, so let's stop here. If you have any doubts, you want any revision class, then you can tell me. We are two faculties who give revision classes, me and Shamsar. So he's senior than me. So if you want revision class of any topic, you can tell me. In 1 or 2 hours, we will try to complete those topics.
Okay, sir.
Just told Nishkarsh, if you want to revise any topic, we will arrange revision classes.
Yes, sir.
So, okay, so let's stop here.
Thank you, sir.
Okay.
Thank you, sir.
Allah
So,
Okay. Allah Hafiz. Bye-bye.
Allah Hafiz.